Okay, so we're going to go ahead and take a look at the law of science ambiguous case. Now, if something is ambiguous, it's unclear, meaning you could sometimes get one answer that you could justify and sometimes another answer that you could justify. We don't usually like it when things are ambiguous, where it's unclear the situation we have. Now, as it turns out, these are actually not ambiguous. They're very, very clear. It's just they're not clear unless you really stop and actually look, study, and do some diligence on the mathematics that stands behind them. So that the word ambiguous case is really just it's ambiguous at first glance. It is actually every single problem has an answer. There is no ambiguity. We just say it's ambiguous because when we first look at it, it's not clear at a quick glance like ASA is or like AAS is. Those are very clear at first glance that there is a solution. It's easy to find. We have a quick path. These are a little more challenging. So we could, instead of calling it the ambiguous case, we could call it the you got to work a little bit case. So anyway, let's see how that works. So what we call the ambiguous case is when you have a situation where it's SSA, also known as ASS. Now, as such, the way that's going to work, anytime you have that kind of ASS case, I'm going to go ahead and draw this version of it right here. The idea would be something like that we have an angle ABC, and I know angle A right here. And then we have angle side C and side A. That would be angle side side. And these are all given. Each of these things that I have listed are given. And let's say I'm wanting to know what this side right here is, but these are given. Now, in the previous video, what I tried to stress is what you have to have in these problems is you need to have a side and an angle that are across from it. So in this case, I would completely be able to say that the sine of angle A, which I know, divided by A, that again I know, would be the sine of B that I again know, all divided by the only thing that I don't know, which is that one. That mathematically means I have the ability to go and solve that problem. So there we go. But here's the problem. And this will take me a moment to describe, but there's actually a few cases. One of those cases is this. What if I told you I had this nice long ray, and that's how I usually start it, is see this bottom side? I don't know how long it is. So it's going to fit somewhere on here. And let's say I gave you an angle. And it doesn't really exactly matter what angle I give you. So I guess I'm just going to go something like this. And I'm going to make this 2 inches, okay? So I've got this 2-inch section right here sitting at an angle of, let's say this is about 34 degrees. Nothing particularly special. But what I'm going to do is I'm going to go ahead and do this a couple of times. So I'm going to try to mimic that and do another 2-inch one right here. So I have the same story multiple times. So notice my angle and my side. So what's going to happen is I'm going to give you one more side that's out here across from. See, again, the only angle I have is A, and so I'm going to give you one that's across from that angle. But we're going to look at it a couple of different ways. I'm going to do one more down here at the bottom. So I have this set up because there's actually 3 cases. So here we go. Let's go one more, a nice little 2-inch section. Now, here's how this is going to play out. And I have a compass here for a good reason. So let's say that I told you that this side right here is angle B. And I'm telling you off to the side that little b is, say, something like 3 inches. Well, I know that somehow this side is going to connect up to here and it's going to land somewhere in here, but it needs to be exactly 3 inches long. So what I'm going to do is I'm going to go ahead and take my compass right here and I'm going to open it up. I hope I can make it that big to 3 inches. Okay. Now, specifically, the reason I did 3 inches is specifically it is now longer than the one that I have. Well, if it has to connect right here, the only place it can hit is all the way out here because as I swing it over and I try to hit that section, the only place it can hit this side is right there. So when we do this, there is literally one and only one place where that can hit. So this is exactly one triangle because that has to sit right here. This is the only place it can fit. And so we can set up our story and we could say then that the sine of 34 degrees divided by the side that's across from it is equal to the sine of, well, I guess I'll call this one A and this one C, would be the sine of some unknown value C over 2. Now, in the previous video, we did some of these, so I'm going to multiply both sides by 2. And I could say that 2 times the sine of 34 divided by 3, but then keep in mind we now have that the sine of some angle C is 0.373. And I'm just going to take the inverse sine, remember, second sine of that answer, or I could type in 0.373, and I found out that this angle is 21.88 degrees. Actually, 21.89 degrees. Now, keep in mind, if I have 21.89 right here, I figured that out, I could find this angle too using 180 degrees, and I could keep going. I could find all of the missing pieces if I did the law of sines one more time. Now, this is what a lot of times we would call case number 1. Case number 2 looks like this. What if this time I said, instead of giving you this really big number relative to this guy, what if I gave you a small number? Like I said, okay, B is only 3/4 of an inch. So I'm going to do that. Let me see. So I'm going to go ahead and take my compass and I'm going to make it small. Now, again, keep in mind, I made the first one bigger than this side, and now I'm going to choose to make it smaller than this side by a little bit. So I've got about 3/4 of an inch. So I come up to here, and I know I want to swing that down and find the place where it hits. And you'll notice it's not long enough to match. It literally can't do it. There is nowhere for me to make that happen. So this is a case where there is no such triangle. Now, I'm going to go ahead and do something just because we can, but what if somebody said, well, wait a minute. No. This is fine. This is 2 inches. You told me that this side over here is 0.75. Now, notice that I just said that 0.75 was not long enough to reach that missing side. Like I couldn't get there. So let's just see what happens if we try to solve this kind of problem because we made a mistake and we thought it was long enough. Well, let's see. The sine of 34 divided by 0.75 is equal to the sine of C over 2. Now, that's what the law of sine says. It says the sine of an angle divided by the side across from it equals the sine of the angle divided by the side across from it. So I'm going to multiply both sides by 2. Let's see. Okay, let's see. Now I'm going to see what happens. I'm going to take 2 sines of 34 divided by 0.75. And it gets me that the sine of C is 1.49. Now, this is a problem. The sine, this is important, is divided by the opposite divided by the hypotenuse. But in any triangle, the hypotenuse has to be the longest side, right? So if you took the opposite and divided it by the hypotenuse, you'll have a fraction where the top, remember the sine is opposite over hypotenuse, the top has to be smaller than the bottom. So if you take a fraction where the top is smaller than the bottom, you will always get a fraction or a decimal that's less than the number 1. And I got a number that's bigger than 1. That means that somehow the opposite side is bigger than the hypotenuse, which is it's not possible. So I can see how the math is telling me something is wrong. The picture is telling me something is wrong because there is no triangle that exists that makes this work. But even further, if you're like, oh, but I'm just moving along and I'm trying it, we get bailed out because I'm going to go ahead and take the second sign to try to find that angle. Now we should know something's wrong of 1.49, or I could hit answer, doesn't matter. My calculator says, no, you cannot do that. That is impossible. So my picture says no, my calculator says no, the trig says no. I think we have no such triangle. That's why we call this ambiguous, because sometimes you get a nice, well-defined answer and it just works. Sometimes you get no answer of any kind, it just doesn't work. And here's the last case. This is the hardest one. And that would be, what happens if I told you maybe this time we had the side 1.25 inches. Now, again, I'm just trying to pick a number that is shorter than this, but not a lot shorter than this. Now, again, let's see what happens if I do that. So if I go to 1.25 inches, which is about right there. Okay, well, let's see what happens. When I try to look for it, it's possible that it hits right here. Meaning this is a triangle that is a valid triangle. But as it turns out, if I keep going like this, it also hits over here. So the question is, could it also sit right here? So I've got 1.25 here. I've got 1.25 here. Again, we said that this angle was 34 degrees. So effectively, I have two options. I've got this one triangle sitting over here that is clearly obtuse. It has the 2 inches that I required. It has the 34 that I asked for. It has the 1.25. That has all of those criteria. But I also have this other one that is not an obtuse triangle that shoots out this direction, where the angle pops out that way as 1.25 as well. Well, what do you know? These are two answers that both satisfy that data. This is the reason we avoid angle side side, because these are clearly not congruent triangles. That's a bummer. But turns out we can still solve them. We just have now two valid triangles to solve. Now, I'm going to go ahead and start this, but I don't think I'll finish the whole thing because once we get it started, you would be able to finish. Okay? So I'm going to solve the easier one first. That's the sine of 34 divided by the side that is across from it equals the sine of, let's see, I'm making sure that I have this set up like I did on the other ones, would be the sine of some angle C divided by the side that's across from it. So let's see. I'm going to multiply both sides by 2, just like we've done on every other problem. Multiplying by 2, I have 2 times the sine of 34 divided by 1.25. I've got that the sine of some angle C is 0.895 degree, 0.895. I'm going to take the inverse sine of that. The inverse sine of that gives me that this angle C is about 63.5 degrees. That's this angle right here. Now, again, I really don't want to do the whole problem, but please understand, if I have this answer, I could utilize that using 180 minus 34 minus 63.5 to get this as 82.5. And then I could use the law of sines one more time, and I could say the sine of 34 over 1.25 equals the sine of 82 over some angle side A. I could solve that if I wanted to. So it's not ambiguous. I could find it. I got all my data. But the tricky part is, how do we come over here and find out about this other weird triangle? Well, here's what happens. If this angle right here is 63.5, then if you look at this little triangle that's sitting inside my diagram that links these two together, then this little triangle right here is isosceles, making if this angle is 63.5, then so is that angle right there. And that is the key, because in the picture, these two things right here would be linear pairs. This angle plus this angle make a line, and therefore they need to add up to 180 degrees. So if I take 180 and subtract 63.5, I'd find out that this angle right here is 116.5 degrees. And now I can do it, because I could say that the sine of 34 over 1.25 would be equal to, but see, look what I've got. I've got two of the angles, so I could find the third angle. And so that would make, using 185, this angle up here at the top is 29.5, would be the sine of 29.5. Oops, I just kind of messed that up. Let me fix that. I want to not say 29.5, I want to say the sine of 29.5 divided by the possible little a. And so I have these two little triangles that are there. And that's the subtlety to this problem that not everybody understands, is that these two angles right here are supplements of each other. And it would not be clear until you work on it. But as it turns out, mathematically, the sine of 10 is this little decimal point 17. The angle that is supplementary to 10 is 170 degrees. And so if we try to take the sine of 170 degrees, we're going to get exactly that same thing. So as it turns out, no matter what, if you take any angle, in fact, I'm going to use this calculator because it has a bigger screen, so it'll show you what I'm doing. Let me quit and clear all of that stuff. In degree mode, what I want you to see is that if you took the sine of any angle and you hit enter, it is the same as its supplement. 180 minus 18 would be 162. And what you'll notice is you get the same answer. So the key to those problems is anytime you have that A angle side where there is possibly two triangles, the key is you would find your primary angle this way and subtract from 180, and that will give you that potential second answer. That's pretty tricky. All right. Hopefully that was helpful, and maybe we'll have a third video where I actually go through the process of solving for one of those. Okay, I will talk to you later. Bye-bye.